Bismillahirrahmanirrahim. Assalamualaikum. My name is Muhayyidin bin Mahmud Muhayyidin.
My name is Muhammad AFIQ bin Muhammad ZAIDI.
My name is Muhammad AIMAN bin Muhammad GHAZALI.
My name is HADI bin SHAIFUL BAHRI.
Okay, so today we will explain about topic is She Gorgeous, see what AI says. So in this topic, we will see how AI identify someone beautiful or average. Next. Hadi. Okay. So how to describe beautiful faces? It is not an easy task since the concept of measuring facial beauty is very subjective and varied. For example, the variation of race, culture, and era will be the most challenging part to learn. So we use deep learning called convolutional neural network CNN to learn input images of faces. CNN will undergo weight training until it get the desirable output. We use the data based on the dataset owner's preference of gorgeousness. The dataset has 4,000 trained data image and 300 test data images. Next, please. So we have a total of 4,300 data, which is formatted in 224 times 224 pixels. So for trained data, we have 2,000 image for beautiful and 200 image for average. And for the test data, we have 150 images for both beautiful and average. We changed the format to grayscale to ease the process. Next.
Okay, I will be explaining about ANN architecture. In a commonly used ANN architecture, the neurons are arranged in layers. An ordered set, which is a vector, of predictor variables is presented to the input layer, and each neuron of the input layer distributes its value to all of the neurons in the middle layer. In our case, the input layer consists of 224 times 224 inputs, total to 50,176 inputs, and the outputs must be 2 outputs because there are only 2 possible outcomes, which is 0 until 1. Next. This is the model summary after we run several hyperparameters using trial and error. A sequential model is built so that the data can be trained and validated to achieve the accuracy. There is a flattened layer that we use to transform a 2-dimensional matrix of features into a vector that can be fed into a fully connected neural network classifier. We also used a learning rate of 0.01 and a hidden layer with ReLU activation function. The model is again compiled with optimizer Adam with loss sparse categorical cross-entropy. Next. The hyperparameters that we use throughout the experiments are number of epochs, learning rate, activation function, number of training data, number of neurons, initial weights, number of hidden layers, and also batch sizes. The first one is number of epochs. Number of epochs is one cycle through the full training dataset. Second one is learning rate. It controls how quickly the model is adapted to the problem. Next, activation function. Mathematical equations that determine the output of a neural network. A number of training data is initial set of data used to help a program understand how to apply technologies like neural networks to learn and produce sophisticated results. Number of neurons is mathematical functions that model the functioning of a biological neuron. Next, initial weight is a parameter within a neural network that transforms input data within the network's hidden layer. Number of hidden layers is located between the input and output of the algorithm. And lastly, batch sizes. Batch sizes is a number of samples processed before the model is updated. Next.
Assalamualaikum, I am FADHLUL Hadi bin Saiful Bahri, and I will explain about the experiments that we conduct. Okay, firstly, there are parameters that we keep constant and there are parameters that we keep change to find the finest test accuracy for our experiment for our project. Okay, firstly, constant hyperparameter. We keep our train data constant at 4,000. We also keep the test data at 300. The initial weight, batch size, we keep it at default. And activation function, we always use ReLU because ReLU is our can give best accuracy instead of other activation function. Okay, and optimizer, we use Adam. Alright. For the change hyperparameter, we keep changing the epoch, either 100 or 200. And for the number of layer, we keep changing from 1 and 2. For the number of neurons in each layer, we always use 128 and 256. And the learning rate, we keep it at 0.05 and 0.01. This is the example of our experiment. Firstly, we put it, for this experiment is activation function ReLU, 2 hidden layer because of the 2 layer dense here, and 256 number of neuron. Learning rate is 0.05 here, and we use Adam, optimizer Adam. Okay, for this epoch we use 100. This is all the change hyperparameter that we explained from the last slide. Okay, for this experiment we got the accuracy of 0.79. Okay. This is the highest accuracy experiment that we conduct, which is we use only one layer, 256 number of neuron in the layer, activation function ReLU, optimizer Adam, and learning rate 0.01. Also epoch is 100. Okay, we got the highest accuracy, which is 0.7967 compared to our other experiment. This is the result of all experiments that we conducted, or total of 16. We differentiate all of the experiment like hyperparameter like epoch, learning rate, number of neuron in each layer, number of layer. So we got the highest accuracy is 0.7967 and the least is 0.5. Okay. Thank you.
Okay, thank you, FADHLUL Hadi. So my name is AFIQ bin Muhammad ZAIDI. So next, we're gonna proceed with the part which is the result. Okay, the first one, in terms of response time, we use Anaconda Jupyter Python to train and test the dataset that we have loaded from the directory. And the accuracy of the dataset is 79.7%. Even though it takes time to process the experiment, we keep with the accuracy of the data. And the next one is in terms of memory usage. Anaconda Jupyter optimizes our operation in running the experiment, and the expected file loaded into the memory is 2.5 GB. And 2.5 GB memory remain unchanged even we try to use different hyperparameter in running the experiment, like explained by the FADHLUL Hadi before. And for the third one, in terms of number of epoch, network reach 79.67%, accuracy in less than 101 epoch after doing several experiments using the different hyperparameter such as estimation function. And that's one. Next, advantage and trade-off. So the data can easily download from the website in the zip file format, and we can extract the file to make it easier to load in the Jupyter notebook. And from the website, we get consolidated data which is combine the training, test, and validated image in the single data sets. Okay, so accuracy of 7.67, we have to sacrifice the performance, which is increase the epoch from 50 to 100. And we stick to gaining accuracy and sacrificing performance so that we can rely on the program to accurately predict, even though it is slow to process the experiment. So we can conclude that if we want to increase the number of epoch, we will increase our accuracy and the performance of our experiment. It will be slow. So I think that's all for me.
Okay, this all for our report presentation. Then we proceed to our coding here. Okay, I will explain the first part. Firstly, we use the TensorFlow. We use NumPy, we use the Matplotlib PyPlot to create graph, we import OS, and we got CV2. Okay, here firstly we download our data from Kaggle website. Then we in form of zip, and then we extract them and we put it in directory in our PC or laptop. Okay, then we declare the directory here for the train data and for the test data. Okay, for your information, our data that we download from Kaggle is in form of image. So we group them in one file that we call them here. Okay, the categories we declare here is average and beautiful. Okay. For the category, okay, this is the path where the image will between the beautiful and average. So firstly, we convert it into the grayscale using this CV2 average grayscale, and we want the graph here to show in gray. So we put here gray. This is the sample how the data will look like. Okay, here we call image array. Okay, the image shape is 224 times 224 pixel. Okay, so we keep it 224 because the data set already said that all the image is 224 times 224. Okay, then we create the train data here. To here in train data, we use the image in the train data directory. Meanwhile, for the test data, we use the image from our test data directory. Alright. Then we print the train data. Here state is 4000. Okay, again we print the test data 300. Then because of the data in the file is already sort the average first, then beautiful. So we need it to shuffle. So we use the here random shuffle data train. We use input random. We use random shuffle data train data and test data to shuffle, so that the image when the computer read it, it will be shuffle. So it will not average. Then after average has n beautiful, but it will be like here 1 0 1 1 beautiful average, beautiful average. Okay. Okay, next here we declare that the image in and label in the train data is x1 and y1, so that it is here. Then we pickle data so that we can call it if we need other coding, we can just call it the pickle here, so that it can import the train data and test data. Okay, proceed to Muhayyidin.
Okay, next we call back the train data and test data using where we pickle just now. And then from the data that we pickle, we divide it by 255 for, as you know, RGB characteristic, where 0 is black and 255 for white. Then we try to print some sample of the image, where as you can see it's already shuffled beautiful average, beautiful, and in grayscale format. Next.
Okay, for the coding, we use keras sequential to define our sequential model. For the first layer, we use flatten and we input the image sizes in the layer, which is 224 times 224 to flatten the image. Then in the coding stands for layer in the neural network. In the next layer, we use ReLU activation function and input 256 units in the hidden layer. For the last layer, which is output, we input 2 units in the layer. Then we define our optimizer by using keras optimizer Adam with a learning rate of 0.01. We then compile our model with optimizer Adam with loss sparse categorical cross entropy. Then we print our model summary, and this is the model summary we obtain. Then we train the data images by using 100 number of epochs, and to evaluate the model accuracy, this is the example of the model summary that we run. Then to evaluate the model accuracy, we use test loss. Then we get the test accuracy 79.76%.
Thank you, AIMAN, for the great explanation. So now we proceed on how to plot a prediction image after we have some training and then going a few experiments. And now based on the coding, so we can see that if the predicted label is true, so the color is blue, or else the color is red, is the label is going to false. And so have a look at the example below. Okay, so example for the image number 2, we try to predict the test image and test label. So we can see that the result average 90%. So is it true that we got a image that's average, because we can see that the binary output, which is a 0. And for the second image, which is image number 5, the beautiful 90%, so average. So, but unluckily, the result is going to wrong, and using the binary result, we get a 1. Okay, because the image is beautiful. And for image number 4, which is image number 3, which is image 21. Okay, so based on the result, it's a beautiful 90%, and the result is correct because we got the result in binary is number 1. Okay, last one. For the last one, we try to plot a few image, 15 image, and we try to predict, and then we, based on the result, we find that there are 4 image with a wrong answer or predictions. And I think we can relate with our accuracy in the experiment, which is 79.67%. And I think that's all from me. Thank you.
Alright, settle.